Good day everyone, I am Charmaine Kilat and today we're going to talk about network security and monitoring. So, sections and objectives. LAN security. Explain how to mitigate common LAN security attacks. Describe common LAN security attacks. Explain how to use security best practices to mitigate LAN attacks. SNMP. Configure SNMP to monitor network operations in a small to medium-sized business network. Explain how SNMP operates. Configure SNMP to compile network performance data. Cisco Switch Port Analyzer or SPAN. Troubleshoot a network problem using SPAN. Explain the features and characteristics of SPAN. Configure local SPAN. Troubleshoot suspicious LAN traffic using SPAN. So, LAN security. Common LAN attacks. Common security solutions using routers, firewalls, intrusion prevention system or IPSS, and VPN devices protect layer 3 up through layer 7. And layer 2 must also be protected. And common layer 2 attacks include CDP reconnaissance attack, telnet attacks, MAC address table flooding attack, VLAN attacks, and DHCP attacks. CDP reconnaissance attack. The Cisco Discovery Protocol or CDP is a proprietary layer 2 link discovery protocol enabled by default. It can automatically discover other CDP-enabled devices. CDP information can be used by an attacker. Use the no CDP run global configuration command to disable CDP globally. Use no CDP enable interface configuration command to disable CDP on a port. Another LAN security attacks is the telnet attacks. There are two types of telnet attacks. The first one is the brute force password attack. Trial and error method used to obtain the administrative password. The second one is the telnet DOS attack. Attacker continuously requests telnet connections in an attempt to render the telnet service unavailable. To mitigate these attacks, use SSH, use strong passwords that are changed frequently, limit access to the VTY lines using an access control list. Use AAA with either TACAX Plus or Radius protocols. The other one is MAC address table flooding attack. Common LAN switch attack is the MAC address table flooding attack. An attacker sends fake source MAC addresses until the switch MAC address table is full and the switch is overwhelmed. Switch is then in fail open mode and broadcasts all frames, allowing the attacker to capture those frames. Configure port security to mitigate these attacks. VLAN attacks. Switch spoofing attack. An example of a VLAN attack. Attacker can gain VLAN access by configuring a host to spoof a switch and use the 802.1q trunking protocol and DTP to trunk with a connecting switch. Methods to mitigate VLAN attacks. So these are the methods to mitigate the VLAN attacks. Includes explicitly configure access links, disable auto trunking, manually enable trunk links, disable unused ports, make them access ports and assign to be a black hole VLAN. Change the default native VLAN. Implement port security. DHCP attacks. There are two types of DHCP attacks. The first one is DHCP spoofing attack. An attacker configures a fake DHCP server on the network to issue IP addresses to clients. And the second one is DHCP starvation attack. An attacker floods the DHCP server with bogus DHCP requests and releases all the available IP addresses. This results in a denial of service or DOS attack as new clients cannot obtain an IP address. And methods to mitigate DHCP attacks are configure DHCP snooping and configure port security. LAN security best practices. First is secure the LAN. Strategies to help secure layer 2 of a network are the following. Always use secure variants of protocols such as SSH, SCP, and SSL. Use strong passwords and change often. Enable CDP on select parts only. Secure telnet access. Use a dedicated management VLAN. Use ACLs to filter unwanted access. Another one is mitigate MAC address flooding table attacks. Enable port security to prevent MAC table flooding attacks. Port security allows an administrator to do the following. Statically specific MAC addresses for a port. Permit the switch to dynamically learn a limited number of MAC addresses. When the maximum number of MAC addresses is reached, any additional attempts to connect by unknown MAC addresses will generate a security violation. Mitigate VLAN attacks. So to prevent basic VLAN attacks, disable DTP or auto-trunking negotiations on non-trunk ports and use switch port mode access. Manually enable trunk links using switch port mode trunk. Disable DTP or auto-trunking negotiations on trunking and non-trunking ports using switch port non-negotiate. And change the native VLAN from VLAN 1. Disable unused ports and assign them to an unused VLAN. Mitigate DHCP attacks. To prevent DHCP attacks, use DHCP snowing. With DHCP snowing enabled in an interface, the switch will deny packets containing unauthorized DHCP server messages coming from an untrusted port. Unauthorized DHCP client messages not adhering to the DHCP snowing binding database or rate limits. DHCP snowing recognizes two types of ports. The first one is the trusted DHCP ports. Only ports connecting to upstream DHCP servers should be trusted. And the second one is the untrusted ports. These ports connect to hosts that should not be providing DHCP server messages. Secure administrative access using AAA or authentication, authorization, and accounting. So in local AAA authentication, client establishes a connection with the router, and same with the server-based AAA authentication. And in local AAA authentication, AAA router prompts the user for username and password, and same also with the server-based AAA authentication. And router authenticates the username and password using the local database and allows user access. It is in a local AAA authentication, and in server-based AAA authentication is the router authenticates the username and password using a remote AAA server. The AAA router uses Terminal Access Controller Access Control System or Remote Authentication Dial-in User Service protocol to communicate with the AAA server. Another LAN security best practices is secure device access using 802.1x. IEEE 802.1x standard defines a port-based access control and authentication protocol. Restricts unauthorized rotations from connecting to a LAN. The authentication server authenticates each workstation connected to a switch port before making any services available. Supplicant. It requires access and response to requests from switch. And the authenticator controls physical access to the network based on client authentication status, and the authentication, it performs client's authentication. So we're going to proceed in SNMP. So, introduction to SNMP. Simple Network Management Protocol or SNMP enables network administrators to monitor and manage network nodes. The SNMP system consists of three elements. The first one is SNMP Manager. Collects information from an SNMP agent using the GET action. Changes configurations on an agent using the SET action. And the second one is SNMP agents or managed node. So the third one is the Management Information Base or MIB. It stores data and operational statistics about the managed device. SNMP operation. SNMP agents that reside on managed devices collect and store information about the device. This information is required by the agent locally in the MIB. SNMP manager then uses the SNMP agent to access information within the MIB. SNMP agent responds to SNMP manager requests as follows. First is get an MIB variable. The SNMP agent performs this in response to a GET request PDU from the network manager. And the second one is set an MIB variable. The SNMP agent performs this in response to a set request PDU from the network manager. So these are the operations. Get request, it retrieves a value from a specific variable. Get next request retrieves a value from variable within a table. The SNMP manager does not need to know the exact variable name. A sequential search is performed to find the needed variable from within a table. Then get bulk request retrieves large blocks of data such as multiple rows in a table that would otherwise require the transmission of many small blocks of data. Only works with SNMP v2 or later. Next is the get response. Replies to a get request, get next request, and set request sent by an NMS. And the last one is set request. Stores a value in a specific variable. Next is the SNMP agent traps. A network management system NMS periodically polls the SNMP agents using the GET request. Using this process, SNMP can collect information to monitor traffic loads and to verify device configurations of managed devices. SNMP agents to generate and send traps to inform the NMS immediately of certain events. Traps are unsolicited messages alerting the SNMP manager to a condition or event such as improper user authentication or linked status. SNMP versions. So these are the SNMP versions. All versions use SNMP managers, agents, and MIBs. This course focuses on versions 2C and 3. A network administrator must configure the SNMP agent to use the SNMP version supported by the management station. Community strings. SNMP v1 and SNMP v2 use community strings that control access to the MIB. There are two types of community strings. The first one is read-only or RO, provides access to the MIB variables but no changes can be made. The next one is read-write or RW, provides read and write access to all objects in the MIB. Management Information-Based Object ID. The MIB defines each variable as an object ID or OID. OIDs uniquely identify managed objects, are organized based on RFC standards into a hierarchy or tree. Most devices implement RFC-defined common public variables. Vendors such as Cisco can define private branches on the tree to accommodate their own variables. CPU is one of the key resources. It should be measured continuously. An SNMP graphing tool can periodically poll SNMP agents and graph the values. The data is retrieved via the SNMP GET utility. SNMP v3. SNMP v3 authenticates and encrypts packets over the network to provide secure access to devices. It provides three security features. The first one is message integrity and authentication. Transmissions from the SNMP manager to agents managed nodes can be authenticated. Second one is encryption. SNMP v3 messages may be encrypted to ensure privacy. And the last one is the access control. It restricts the SNMP managers to certain actions and specific portions of data. Configuring SNMP. Steps for configuring SNMP. These are the basic steps to configuring SNMP. First is configure the community string and access level using SNMP server community string RO or RW command. Optional, document the location of the device using the SNMP server location text command. The third one is optional. It is also optional. Document the system contact using the SNMP server contact text command. Number 4, use an ACL to restrict SNMP access to NMS hosts or SNMP managers. Reference the ACL using SNMP server community string access list number or name. Another configuring SNMP is verifying SNMP configuration. SNMP best practices. SNMP can create security vulnerabilities. For SNMP v1 and SNMP v2c, community strings should be strong and change frequently. ECLs should be used to prevent SNMP messages from going beyond the required devices and to limit access to monitored devices. SNMP v3 is recommended because it provides security authentication and encryption. The SNMP server group name v1, v2c, and v3 auth note command creates a new SNMP group on the device. The SNMP server username group name command is used to add a new user to the group. Steps for configuring SNMP v3. So these are the steps to configure SNMP v3. First is configure a standard ECL that will permit access for authorized SNMP managers. Second, configure an SNMP view to identify which OIDs the SNMP manager will be able to read. Third, configure the SNMP group and features including name, version, type of authentication, and encryption associates view to the group, read or write filter with ECL. And the last one is configure a user with features including username, associates with group, version, authentication type, encryption type, and password. SNMP v3 configuration. The example configures the standard ECL name permit admin. It is configured to permit only the 192.168.1.0/24 network. All hosts attached to this network will be allowed to access the SNMP agent running on R1. An SNMP view is named SNMP RO and is configured to include the entire ISO tree from the NID. Cisco Switch Port Analyzer. Span overview. Port mirroring. Port mirroring allows a switch to copy and send Ethernet frames from specific ports to the destination port connected to a packet analyzer. Analyzing suspicious traffic. Span is a type of port mirroring that allows administrators or devices to collect and analyze traffic. Span is commonly implemented to deliver traffic to specialized devices, including packet analyzers, using software such as Wireshark to capture and analyze traffic for troubleshooting purposes. Intrusion prevention systems. IPS are focused on the security aspect of traffic and are implemented to detect network attacks as they happen. Span can be implemented as either local span or remote span. Local span. Local span is when traffic on a switch is mirrored to another port in that switch. A span session is the association between source ports and the destination port. There are three important things to consider when configuring span. So the first one is the destination port cannot be a source port and the source port cannot be a destination port. The number of destination ports is platform dependent. And the last one is the destination port is no longer a normal switch port. Only monitored traffic passes through that port. And these are the terms of local span. Ingress traffic, this is traffic that enters the switch. Ingress traffic, this is traffic that leaves the switch. Source span port, this is a port that is monitored with the use of the span feature. And destination span port, this is a port that monitors source ports, usually where a packet analyzer, IDs, or IPS is connected. This port is also called the monitor port. Span session. This is an association of a destination port with one or more source ports. And the last one is source VLAN. This is the VLAN monitored for traffic analysis. Remote span. Remote span allows source and destination ports to be indifferent switches. RS span uses two stations. One station is used as the source and one station is used to copy or receive the traffic from a VLAN. And the last one are the traffic for each RS span station is carried over trunk links in a user specified RS span or VLAN. And the terms of the remote span are RS span source station. This is the source port VLAN to copy traffic from. RS span destination session. This is the destination VLAN port to send the traffic to. And then the RS span VLAN. A unique VLAN is required to transport the traffic from one switch to another. The VLAN is configured with a remote span VLAN configuration command, and this VLAN must be defined on all switches in the path and must also be allowed on trunk ports between the source and the destination. And span configuration. Configuring local span. A session number is used to identify a local span session. Use monitor session command to associate a source port and a destination port with a span session. A separate monitor session command is used for each session. A VLAN can be specified instead of a physical port. So another span configuration is verifying local span. Use the show monitor command to verify the span session. It displays the type of the session, the source ports for each traffic direction, and the destination port. Span as a troubleshooting tool. So, troubleshooting with a span overview. Span allows administrators to troubleshoot network issues. To investigate a slow network application, a network administrator can use span to duplicate and redirect traffic to a packet analyzer such as Wireshark. Older systems with faulty NICs can also cause issues. If span is enabled, a network technician can detect and isolate the end device causing the problem. So that's the end of my report. Thank you so much for watching and God bless us all.